Hello friends, in this video I'll be discussing the third question from today's weekly contest, that is 360 reload contest. And here is the question. You have to find out minimum operations to form subsequence with target sum. Yeah, so you are given array and you are given in target. And in the array, what will be the values? The values will be power of 2 only. Nothing else, just power of 2, right? Even if you can see 1 is there, 2 is there, 8 is there, all are power 2 of 2, right? Power of 2 are what? 1, 2, 4, 8, 16, 32. So all those numbers can be found only in the array. So that is definite, okay? And then yeah, yeah. So clear about inputs. Let's get into operation. So in operations, what you can do is you can choose any number from the array and you can remove that number, and at the same time you can add two numbers that will be half of the removed number. If you have 1 to 8, you can do 1 to 4 4. After removing 8, you are doing in 2 increases, right? And here, after doing these operations, are you getting target? Yes, you are getting 1 to 4. That sums to 7. So with one operations, you are getting this output, right? You are getting this target, and that is and then output is the number of operations, that is 1. So okay, so number of operations is not just enough. You have to have minimum number of operations. So you have to find out the minimum number of operations on that given array so that you can find out a sum of target, right? And sum of target does not mean that you have to sum up all the elements. No, you can just sum few elements, either 1 to this 4 or 1 to this 4, right? Or anyway you have to, and even if you sum all the numbers, you are not getting 35. So in that case, if you are never getting that target, then you have to return -1. Okay? And okay, looking to constants, so number of elements will not exceed 1000, that is 10 to the power 3. So it means that you can apply an algorithm of at most n square. Yeah, and these are numbers. I don't think this matter. Okay, yeah, nums only consist of non-negative power of 2. That's it. Then let's look into the approach which we will follow. Guys, first thing that we will do is sort the numbers from the array. After sorting, we will see that any number, if we are encountering later in the right side, that should always be greater than all the numbers in the left, or at least equal to the numbers in the left, right? And obviously all the numbers are to the power something, right? And another thing is you have to split the target, right, into power of 2. Right? So here 40, if 40 is the target, you can split it to 4 plus 8 plus 16. So all of these are power of 2, right? I'll share while implementation how we can split the target into the power of 2. And after splitting it, uh, these values have to be arranged into increasing order as well. So these will be in increasing order, and these numbers will also be in increasing order. After getting these two things in the increasing order, so now you can see that these power 2 of 2 are given, and this power of 2, this unique power of 2, that you have to find out so that it sums to 40. Okay, so the algorithm that I'll apply is like okay, let's write the logic here. If you traverse from left to right for nums and for target as well, these are three conditions that can occur. First condition is required power is equal to nums. Like required power is here is 4 if you're starting from left, and nums is 1, right initially. If these are equal, then just use this power for target. Okay, so use required power for target. And so this is the first condition. Second condition is required power is lesser than nums. So in case required power is 32 and your nums is 8, then obviously you will achieve this condition. And in that case, what you have to do is you can do operations on num side to update a storage. Okay, and then you can update a storage. So what is storage is, I think, okay, let's share this. So I'll be storing elements which are not being used, right? If one is not being used to achieve target, then I will just store this one somewhere, right? And again, so any element which are not being used to be in the target, okay, to sum up to the target, that we will store somewhere, right? And okay, so this is about this. So you do operations, after doing operations, you check if you are getting required power, and whatever you are using in to find the required power, obviously you will get the required power because num size is greater. So if required power is 4 and num size is 8, then you can just split it into 4 and 4. Obviously you will get required power. So whatever number is there, whatever this number is there, you will always get required power, right? Because if the required power is 2 and this number is kind of 8, then you can first divide into 4 and 4, and then you can divide to 2 2 2 2 4 times, right? So or 2 2 and 1 is 4, obviously. So you can just split into 2, split into 2, some so at some point you will get this required power, right, after splitting this value. So do a split operation on nums I, and obviously add to target. Okay, and whatever will be remaining, whatever values you are not using for the target, you will keep into a storage that as well. So for example, uh, if you have value target as 16, for example, if you have, yeah, not target, let's say required power is 16. Okay, and the other thing is your number is kind of 32. Since 32 is greater than 16, so okay, let's make it something more interesting. So if required power is 8, okay, so if required power is just 8 and you have number as 32, then what you will do, you will split 32 into 16 and 16 first. Still you are not getting required power, so then you will do what you will do, you will split 16 into 8 and 8. So what you will do, 8 8 and third you are not splitting as of now. So here one of these values will be used for the target, so this will be used, and 8 and 16 will be remaining. So the store will be updated with a store sum. So I'm not storing every number, I'm just storing the sum of the numbers which are remaining. So here what we will do is 8 plus 16 which are not used, and 1 8 1 out of 2 8s, just one is being used for the target and two are stored. Okay, so store sim will be updated with 24 addition. Okay, in this case, so this is one example. Okay, so this is how it is. And then okay, so this is the second condition. Third condition is required power is greater than nums. So if required power is 16 and your num is just 4, so obviously you will not just have 4, you may have some store as well. So you can check a store, or you can update the store, and then you can see if this required power is greater than a store, then you can just use that store to achieve that required power, right? So for that you can see this. So yeah, let's understand this assumption. So it says that if required power is 2 to the power v, okay, and your stored values are this many. So obviously you all the numbers are to the power something. So all these are numbers which I have encountered or I have stored somehow. Okay, even if I have split it into even if I have done a split operations, there also I have found some to the power some value. So there also, even if you like a split 32 into 16 and 16, then 16 is also power of 2, right? So everything is power of 2 only. Okay, and all of this power of 2 is smaller than 2 to the power v. Why? Because you have whatever you have already encountered are anyway smaller, because the values are sorted. Okay, so all of these values will be smaller than 2 to the power v, right? So all of these values will be smaller than 10 to the power v. That means v will be smaller than all of these values anyway. Okay, so in that case, if this is the condition, then if you remove to the power v from this, so let's suppose till to the power r of I, if you just take this out, then you are making to the power v, then there will be there will be possible, it will always be possible that you can get another split which will also be uh, available in that uh, sequence. Like, let's understand this with an example. For example, if you have required sum as 8 and your store sum is this many, that means your store sum is 11. If you remove 8 from this 11, then you will always get 3, and 3 means 1 plus 1 plus 1 or 2 plus 1. So if you remove lesser values from 11, and that lesser value will always be to something, in that case you will get the remaining element just somewhere in this store sum, right? and and in the same way, if you do something mischievous, like instead of this store sum, you are having 1 plus 1 plus 8. Obviously this is not our approach. So in case if this is the value and this is coming to 11, okay, let's make it something different. So not 8, let's make it what can be greater value. Okay, so let's suppose this is not just 11, it is kind of 15. And for that we are doing something like this, 4. Okay, and here also I'm doing 4 and 4. Okay, and in this case, like if you are doing 1 plus, it's not 14, it's 15. Okay, in this case, if you are doing something like not 8, you are use, okay, let's make it 17 only. Okay, just one more. Okay, so in case if you're doing something mischievous, you are doing 1 plus 16, and from 1 plus 16, if you're removing 8, then this is not possible, right? Because what you can either split into 1 and 16, or you can split into, or I think there is no other possibility other than splitting 1 and 16. And here you can split into 8 plus 11, right? So here the value will be this 11. Yeah, I think how we can get 8 out of this. So let's pick these two and these two, 6, and then you can just pick all this. If you pick all this, then 6, it will be 9. Okay, I think this is, yeah, you can pick this way. 3, okay, yeah, you can pick what will be picked. So 1 plus 1 plus 2 plus 2 plus, sorry, plus 2 plus 2. Okay, and then remaining will be this remaining whatever you can see of without this. So this will be remaining, this one will be remaining, this will be remaining. You can pick this 8 in various ways. So the way you pick 8 out of this, you can always just split into two sub sequences. One will sum to 8 and the another will sum to 11. Okay, why this is possible? Because all these values are smaller than 8. Even if some value is equal to 8, then also it will be possible, obviously. Okay, so yeah, remove it. So even if it is having equal values, then also it is possible. Even if it is having a smaller values, then it is possible. But if it is having greater values, any greater value, then it will never be possible, right? Okay, it then also it is possible, but there will be a chance that it may not be possible if the value is greater, as you can see here. And here you can play any way. You can try any way. You will always get you can always split into true or b and some values that will also have you that will also have some subsequence, right, from here. So for this also you can find some subsequence here, and here also you can find subsequence that will not be overlapping. So yeah, this was the observation which lead to this algorithm. So this is the main observation which has helped me to write this algorithm. Okay, and here obviously you can see there are three conditions. So okay, let's go to implementation now. Yeah, so first, you are sorting nums, then you are finding required powers. So to find required powers, you are doing some bitwise operations. So in bitwise operations, what you are doing is, if your value is kind of 17, then the least significant power of 2 is 1, and another value is 16, right? So to find one, I'm just what I'm doing is I'm doing bitwise operation like 17 in and 16, like 17 minus 1. And if you will do this AND operation, okay, then you will get the value which is uh, excluding the least significant digit. So B is excluding the least significant digit, and if you subtract from the original number to this excluded value, you will get the least significant digit, and then you can update the value where you have removed the least significant digit, and then you can do this while operation. Okay, so this is to get required power of 2 with some to target. Okay, yeah, using bitwise operation obviously. So yeah, here we are just finding minimum number of 2 powers of 2. Okay, the next thing is, after getting required powers and after sorting those values, we are traversing from left to right. So in nums, we are traversing from left to right, that is in increasing order, and then you are traversing for required power as well. So for required powers, I have this I as index. So if, okay, the first condition, if required power is equal to nums, you are just going to the next required power. So basically, num is always going to be traverse. Num is always going to be somehow uh, done something. Okay, so because for a for loop you will be getting the next num element. Okay, so here if it is equal, then obviously you are going to the next required power, and if num is greater than required power, in that case you will do operations. Why? Because if you have num is 32 and required power is 16. So to make 16, you are splitting into two, 16 and 16, like for 32, and you will, and for that you are finding out the number of operations that you need to do. So to get the number of operations, the small piece, you are finding the small piece, but is the small piece, a small piece is required power. So if required power is 16, okay, required power is 16, and if your num is 32, then how many operations you needed? Just one operations. In one operations you will make 32 as 16 or 16, okay. And in case if required power is 8, in that case your operations will be 2, okay, and you will split into 8 and 8 and 16, okay. So this is a small piece, and you are finding the number of operations. So to find number of operations, just you are doing 8, like 32 by 8, and like that many split you will be doing. So here you will be doing two splits. So 32 splitting into 16 and 16, and 16 is splitting into 8 into 8. So this power of 2, differences in power of 2. So differences in power of 2 means 32 by 8, and that is 4. To make 4, you are just doing like log 2, okay. So there are two operations that you can see. And then here, why this is being done, why this while operations, this is to find out all the used numbers. So here you will not just have one required power. So here you are also increasing required power whenever you are using this a small piece. So it's not just a small piece. So a small piece is like this required power, the initial required power. But yeah, if required power is used for making target, if required power is used for making target, okay, then you are just increasing used, okay. Used is 0 as of now, like before all these while operations, and you are increasing used, and then you are going to the next required power, okay, till required power does not increase, does not have value greater than num, okay, or required power is not being empty, okay. Till then, like all the required powers are not traversed, till then you are just in this while loop. So in case if the required power is exceeded nums, then it will come out of the loop, okay. So for example, if required power is not just 8, required power is also 16, okay. So here, even if you are splitting this into 8 and 16, then 8 and this 16, both of these will be applicable. So here this 8 and this 16 will be applicable. So as many times you are splitting, you are also checking if there is some required power that can be used, that can be yeah, taken from here, okay. If some required power is satisfying if some required power is being fulfilled after this splitting, then it is good, right? Because we will not have to split any other number, because this number, while splitting this number only, we are satisfying as many number of required powers as possible, right? So that's why we are doing these many while operations, and here we are calculating the number of split that we had done here, and then we are splitting the storage. Why we are updating a storage with num minus used? I think I have discussed it. So the num is 32, and you have used 8 plus 16, that means 24. So 8 is remaining, that is storage, okay. That is going to a storage. And in case, so these two conditions are discussed when required power is equal to num or required power is lesser than num, okay. And if required power is greater than num, in that case you have to find out a storage. If you have some storage, and from storage you can use it till the time a storage is not able to satisfy, a storage is not able to fulfill your required power, then you come out of this loop, okay. Or either case, if your required power is all fulfilled, then also you can come out of this loop. And after these conditions, you can find out if all of the requirements are fulfilled, then you have to return answer. Anytime if any while any number consideration, if this requirement is fulfilled, then you have to return answer. And after completing all this loop, all these things you have done, and still if you have not fulfilled this, then you can return -1. Okay, so I think this helped. Guys, if you liked my explanation, please hit like button, and I'll be happy to see if you write some comments about it. Thank you.